Hi, everybody. Uh, this guide is for those practice problems that refer to multiple alleles. They're problems 4 and 5. And multiple alleles is really a really common way for traits to be inherited. You know, like that eye color isn't, you don't have blue eyes or brown eyes, right? Right. But you have an eye color gene, and you could have one copy of the gene that we will call the brown gene or capital B, and it makes a protein that makes your eyes look brown. Another form of that gene we called little b, and it gave you eyes that look uh, blue, right? Well, couldn't there be an italicized B that represented another form of that, another allele, like the green eye gene? Or how about another allele that has a hazel eye gene? And so you can imagine that would give rise to like all kinds of different possibilities for eye color, which is also close to the truth. All right. So let's use our great example for this, the ABO blood group. And the ABO blood group only has 3 alleles. And so let's take a look at that. The ABO blood group, not group, is an example of a gene with multiple alleles, and it has 3. One is the letter I, capital A. I know that's a little bit of a weird convention, but we're going to see it again when we talk about sex-linked problems. I have another copy. We'll use it. I, B, and then last but not least is this lowercase I, and that represents the O gene. All right. And this gives rise to 4 different blood types, the ABO blood group. Type A could be either IAIA or IA little I. All right. And so we kind of have a dominant recessive form here, right? Similarly, type B blood is either you've got 2 copies of the homozygote IB gene, or you have a heterozygous state, right, where you have IB little I. All right. And again, you see dominant recessive here. Now here's where the system is a little odd, right? If I have IA and IB, these guys are codominant. They're expressed at the same time. Okay. And then finally, last but not least, for type O blood, this is the rarest form, is little I, little I. In fact, I think you can make some money if you got type O blood by going to the blood bank. So let's take a look at our first problem. And what looks like classic fashion, question number 4 is harder than question number 5. So let's start with question 5. Mom has type O blood. Dad has type AB blood. What percentage of their kids will inherit type B blood? Now, this is easy because I know mom's genotype. She's little I, little I. I know dad's genotype. He's IA, IB. And so here's the cross. Little I mom, AB dad. And what do I get? Little I with IA and IB. There's 2 phenotypic classes here, type A, type B, in a 1-to-1 proportion. And the question is, what percentage of their kids will inherit type B blood? What's the answer? I got this type and this type. The answer is 50%, So there's a relatively straightforward problem. Okay. Question 4 is a little goofy. Mom has type A blood. Dad has type AB blood. What possible blood types could their children inherit? Well, look. Okay, so again, last but not least, right? Question number 4, the first ABO blood group says mom has type A blood. Dad has AB blood. So, cool. I know dad's blood type. He's this. AB. Mom, though, type A blood, you know, like, what is she? What is she? She could be IAIA or IAI. Right? And that makes this a kind of a goofy example. So she could be either one of these two types, right? So what does that mean? Well, let's take a look. Let's start and assume that she's this heterozygous, right? So here's the Punnett square for the heterozygote. Right? Here's mom, IAI, right? And what do I get? Dad's AB. I get IAIA, IAI, both type A. Dad gives me this, in this box, I get AB blood plus B blood, all right? But I'm not done, all right? Because remember, I have to also consider the case where mom is type A blood, IAIA, not IAI. And dad's AB again. Here I get type A blood, type A blood, type AB blood, type AB blood. So the truth is, when you fully flesh it out, you're going to get type A blood, type B blood, and type AB blood. No examples of type O, so the answer is A, B, and AB. That's the answer. Hopefully that helps illuminate that, and this superscript isn't blowing you away too much, because the next problems are going to be in sex-linked problems, and we're going to use the same model.